introduction to event. Oh, nice. Practical introduction to event sourcing, and examples will be on using EventStoreDB. However, I think that they should be easily to use with any other event store. Examples will be in .NET, in C#, but I think that they are also translatable into the other languages. So yeah, so here I am. I'm Oskar. I have over 14 years of experience, and as I mentioned, I'm working currently as developer advocate at EventStoreDB, but I'm also co-maintainer of Martin, which is open source framework that also allows to use event sourcing. Before I go with the practical part, let's start with the basics stuff. I always like to start with the basics because that can build a common understanding. So let's start with the basic question. What is an event? An event is something that's happened in the past. It gathers some specific information, like eagle has landed, or the meeting started, or shopping cart was initiated, etc. So it's information from the past. And events are immutable because we cannot change the fact unless we read 1984 and we know that we can, but in general, we cannot. What has happened, and what has been seen cannot be unseen. So we can ignore something that has happened, but even if we are ignoring the facts, then it doesn't mean that this fact didn't happen. And we can interpret the different events from a different perspective. Like here we see that some people are extremely happy about rain, some are not. When I was young, I was really enjoying winter time, now not so much. And for example, a football match, if fans of one team has after the match usually totally different emotions than the other one. And of course, events are messages, so we can use them in our IT systems. That's why we gathered today, and that's what we will be discussing. So how to use events technically. And one of my favorite quotes about events and about, in general, event-driven system and event sourcing comes from Greg Young. It means that when we are starting to think about events and when we are building our systems where events are the first-class citizens, then we are stopped thinking about our common approach that we learned. I'm not saying that we should be leaving our comfort zone. I'm not like a coach, but it's kind of good experience when you derail your thoughts and you start to looking at your system from the different perspective. Because I'm not sure how you, but when I was typically speaking with the business people, then I was thinking like, okay, I will build such class, then I will create such table, etc. So events are helping to focus on the business. And in the last years, many modeling exercises or methodics or whatever we name it were invited. One of them is event storming, the other is event modeling. And in general, my guess is that you already know that, but unless you don't know, then you are putting those weird sticky cards on the wall and building your system up from that. And when I first have a look on the event storming, then I thought that, well, that's weird. That's weird. Why should we put those stickers? But it appears that if we use those orange stickers, so we put all of the events that are happening in workflow of our system, then it helps us to discuss, so technical people with the business people, how our system is built, and events are a good checkpoints for our business workflow. So for example, shopping cart was initialized, a product item was added to shopping cart, shopping cart confirmed, then payment recorded, etc., etc. And this is the general building blocks that we can use building event-driven systems and in general all systems. So the main one is domain event, and domain event is a business fact that happened in our system. Comment is an intent to perform some business operation, like for example, add product item to shopping cart. An event, when it was recorded, it's a product item added. All of our operations that happen with our system can happen from the UI, from the external system. We can evaluate policies, and after that, we can refresh our read models based on events. And this is, in general, the flow that solves all cases. So we are getting events, we are running business logic. After that, we are recording business event that then can trigger update of the read model, and then we can send further on next comment, etc., etc. Important thing to an important name to understand event-driven and systems and event sourcing is event stream. Event stream is an ordered sequence of events. So why is it called event stream? Because just like a stream, we cannot go into the same stream twice. I think that that was one of the Greeks that told that some time ago.
Probably, but I don't remember, so.
Miraculous.
Yeah, exactly. So precisely, that's why are we calling that event stream? Because if our system is alive and if we are getting new operations happening, then we won't see the same state of our system. So we don't see the same sequence of events in our system because the new events will be recorded one after another. And as I mentioned, stream is an ordered sequence of event, and typically in I think 99 or maybe 95%, or at least that, event stream representing the specific object. So for example, specific shopping cart, specific entity, etc. If we have more than one shopping cart, then we will have more than one shopping stream. Typically, that's one-to-one relation. It doesn't have to be like that, but just for the simplicity, you may think that event stream is just a history of a specific object. And so that's what I said. If we have more than one, then we will have more than one stream. And as you can see, those events are usually happening, might be happening a bit in parallel. However, if we record it, then our system is typically recording them in a specific sequence. And in event sourcing and event stores, such structure besides a stream, it's called append-only log. So it means that when we are adding new systems to our system, recording new facts in our system, then we are adding. Yeah, so we are adding one event after another, and thanks to that, we are able not only to build history of our specific object, but also the history of our whole system. Of course, if our tool allows us to do that. And let's talk about how this happens in event sourcing. So as I mentioned, each time we are doing a business operation, then we are recording new fact. So at first we are opening shopping cart. After that, we are adding, for example, added a new game like Cyberpunk, but then we decided, no, we won't buy Cyberpunk. It has too many bugs. So we removed it and bought some older game like a Witcher. And after that, we confirmed. So as we see, for the single shopping cart, we are recording one fact after another. Event sourcing also enables time traveling. Because we have recorded all of the history and we know precisely what has happened to our entity, then we can get back in time and see what was the state at the certain point of time. That might be position, or that might be some specific date. So as you can see, but by just getting subset of events, we can check what was wrong, and in general, that enables us high debugging possibilities. So both business-wise and technical-wise. So if we are getting like our support, even user support is getting information that someone said that, yeah, I ordered Cyberpunk, but I got Witcher, then we can see that clearly that wasn't the case, because someone indeed added Cyberpunk to the shopping cart, but then it removed it. So it's a business record, but we also, as we are getting some bug in our system, we can just take a subset of events and even run it locally and debug what has happened. So whether this is a bug in our business logic or something else. We are also getting auditability and tracing. So what's that? In general, in system, not easy to know what's going on, even if we are building monolith. But in a microservice world and cloud world, when we are connecting different pieces together and they are totally autonomous and unrelated deployments, then it's getting harder and harder to understand what has happened. So we can use correlation if we are sending ID of the comment that created, that after processing of that comment, we got those events, then we can see what business operation was a trigger for all of those events to appear. So when we confirmed card, then typically we are sending some email, we are sending some pro forma invoice, and after that, we are printing that invoice. So all of that usually happens after the single operation was started. And we also have causation, because correlation only tells us about a group of events that were recorded after a specific comment was processed. But we still don't know just by that what was the specific order, because as we are humans, then we see that picture and we can understand and visualize what's the order, but computers are not working like that. So we can use causation, which is typically an ID of the previous event. So for example, for card confirmation email sent and pro forma invoice issued, it will be ID of the card confirmed. So we are building like a tree of the operations. And based on that, if we join them with the correlation, then we can precisely have the tracing information and auditability, both from the business perspective, but also from the technical perspective, which makes our life as a developers easier. And let's talk about event sourcing architecture. No, that's not an event sourcing architecture. So maybe that, no, that's also not an event sourcing architecture. So if we see a picture when there is a lot of blocks, and especially when there is a messaging system as a central part of architecture, this is not event sourcing, probably. And what's event sourcing? Event sourcing should not be treated as a general architecture concept for the whole system. Event sourcing should be rather perceived at the specific module scope. And it's perfectly fine for your core domain to use event sourcing, because event sourcing shines the most if you have more advanced business workflows. However, and you may decide that, for example, for some like an inventory where you are just keeping an information about the state of your warehouse, then you might decide to just use a CRUD approach. So event sourcing is a simple pattern, as a storage pattern that should be considered in the specific module scope. And by itself, it does not tell anything about messaging, about messaging buses. It tells about following behavior. So we are getting a command, for example, confirm shopping cart. After the service got this request, then it loads all of the events, so whole history for the specific entity, and it applies that event one by one. And it creates, after applying that, the local representation of the state, usually in memory. And after that, the business logic runs precisely the same way as in a classical approach. So we are doing some ifs, we are checking some policies, but the difference is that after the business logic was processed, then we are creating new event and appending it to the event stream. So we are just recording new fact. And after that, events are stored again, and we can run a follow-up command. And that's what's event sourcing about. So I already told about the business aspect and the most like a philosophical aspect. So let's see how we can model our events technically. So the first, the typical case is that we can think about the events as a JSON messages, like messages that we could store as a JSON format. So typically we have here data, which are specific information about this particular event. And we have some metadata like a stream ID, and stream ID in an event sourcing nomenclature is a entity ID, serial number, which is version. So the version at which the event was recorded. So it is auto-incremented number typically. So we could see what's the order of events in our stream. But, and we can store them in a relational table if we'd like to. That's how we are doing in Martin. We are storing them in a Postgres in relational database. So event sourcing does not speak anything about the storage that should be underneath. I think that you could even implement event store on top of Excel, but not that I recommend it. But if we can also store that as a binary format, and store that is at a disk storage. So precisely that's how we are doing that in EventStore. Because EventStore is a database that was natively built for the event storage, and relational databases also are storing that. Like eventually, it all ends up as files on the disk. So there are plenty of options. If the potential benefit of using binary storage and EventStore is that we can optimize for events storage because we don't have random updates, etc. But yeah, it's up to you to decide what type of you want to choose. Let me check. There is a question from Mark. Why no reason column to chain events? I can maybe briefly just go. ID is an event ID. Type is a type of the event. So for example, shopping cart confirmed. Stream ID, this is the ID of the entity. Serial number is an auto-incremented number in the particular stream. And data is just JSON stored. So the specific data for this particular event. I'm not sure.
So there were, did you answer that one? Because there was a previous one, but I didn't want to interrupt you basically. So it was a question about correlation ID. I mean, so you don't persist correlation or causation ID in this table? Or do you?
I mean, this is a simplified version. If you would like to store that information, then you either have to add additional column, because if we always want to store correlation, then it makes sense to just add obligatory column. Of if we want to support custom metadata, then probably we would have a metadata column with the JSON representation. So, and then we can store all of the, we could store again all of the information there.
And basically, before that question, but I didn't want to interrupt you, there was another one about basically how would we deal like with event streams that become huge. Let's say that you have a shopping cart that was asked by Daniel, and like keep getting shopping cart item event added, shopping cart item added, shopping cart
Mhm.
item added, then the stream gets large. What do you do in that case?
Yeah. So in general, the most important aspect of the modeling in event sourcing and the main difference between the classical approach is that each new state change, new fact is adding more data. So if we will be keeping all of the history for a long living object, then indeed we could get like thousands of events. So getting thousands of events at the one time and then building an entity in memory, of course, that won't be effective. So that's also the reason why a lot of people are starting like, yeah, I might have thousands of events, then I should probably use snapshots. So besides appending event, let's store a current representation of state. But then we are losing the fact that events are our source of truth. So just like the name of the event sourcing comes from that events are our source of truth. So the best option is to try to have a look on our business case from a different angle. Quite often, or even typically, in our business, we can find out some life cycles. Like, for example, I was working in the hospitality industry, and I'm calling myself lucky because my business was always telling that everything is happening for this particular day. So when we are thinking about our event stream, then we should be also thinking about the time dimension. So instead, for example, keeping like in my best example for that is instead of, for example, we have a department shop and we have many cash registers. So if we will be trying to record in the same stream all the events for this particular cash register, then we will have such huge stream and that won't be maintainable. But that's not how this business works. Typically, you have a cashier shift, and few times per day, there is a new cashier shift. So new cashier comes with cash, just put it into the desk and starts the shift with the new record. So we are splitting our cash register into some life cycles. So from one shift to another. If we are starting a follow-up shift after the previous one, then we don't need all of the information about all of the transactions that happened on the previous shift. What we need is just a summary from the previous shift, and we are starting a new one. The same case can be done, for example, for the patient in a medical clinic. Like we could keep all of the records for whole clinic in the same single stream or for the single user, but we can think about that and add like, let's keep a record for the particular date, because typically we are interested in the visits that will happen in the particular date, etc. So to show TLDR is the most important is to keep streams short and discussing that with business and asking about that, because quite often for the business, it's obvious and they are not telling about those life cycles. But if we ask them, then usually they are quite open to explain that. Even in accounting, you also have the accounting month. So you are just summarizing that. And event stores in general, event relational one, like for the relational database having like 50 million of records, if they are properly indexed, then it's not a big deal to filter properly. Of course, if we have short streams. And in EventStoreDB, our operations are in general optimized for such case. So it's scaling really well with the number of streams, and it's able to read quite fast a lot of events, like 100 of events is not exactly a huge deal. especially that those events are small or should be small because they should be focused on the specific information. So as you saw here, we should be having like 3 fields or maybe at most 10. So getting those small events in a single chunk is not precisely an issue. Of course, if we cannot do that differently, then we may consider things like snapshotting, etc. But yeah, the most important part is to focus on modeling streams and making our streams short. And that's also the difference from the approach and maybe our learnings from using Kafka, because Kafka is just a pipe. So you are putting on one side and getting events from the other side. And that's how it goes. So Daniel, I'm not sure if that answered your question. If not, then feel free to drop me a note. And right now, I will get back to that later because we would like to get some coding. I hope so. So yeah, let's start. So let's see how we could represent events in our code. So I will be a bit copy and pasting, so I'm cheating. It's not precisely coding, but that's all what we do, right, on our daily work. So it's it should be quite similar. So
with shoulders of giants.
Yeah, exactly. So I'll be using a bit of the new syntax from C# 9 and 10. And this is record. This is shortened syntax for classes. And events are just can be represented as a read-only, immutable structures like record. So we are creating new, when we are deserializing or storing it, then we are creating new instance, but we cannot change it. So that's aligned with what I said, that you cannot change the past. And events typically are having specialized information, like when we are initializing a shopping cart, then we need for which client we are doing so. In the follow-up events, we don't need that information. So we don't need, because it would be redundant because we have it already here. And if for adding or removing shopping cart, then we are using product item. And for cart confirmation, we don't need that information besides that confirmation date, just for some auditability later on. And what we can see is that all of those events have the shopping cart ID. And that's an identifier that we will correlating our events. So know precisely that those events are meant to be for the specific entity. And in event sourcing, it's not like we are just using events. It's not totally revolution. It's revolution in some ways, but our business logic can still be run and should be run on entities. So if we define our shopping cart, then it's like the current representation of our state. So we'll have the identifier, the client ID, and current status. So the first two we are getting from shopping cart initialized event. Shopping cart status we are updating while we are recording those events. So at first it's pending. After we confirmed, it's confirmed, etc. And we have the product items list that at the beginning will be empty, and we have nullable confirmation date because it will be only set after the shopping cart was confirmed. So no revolution, we are still using entities if we'd like to. And how we can get the state of our entity from our event stream, so sequence of events. Typically, we are defining method that usually is called when. I don't know from where it comes from, but it's more like shopping cart when specific event occurred. So we will be calling that method for each of the event inside our stream, gradually updating our state and getting the most recent one. And how to do that? We can use some pattern matching that let me paste it. And this code was at the beginning quite weird for me, but I thought that I'm not sure if I love it or hate it, but now I think that it's more love than hate relationship. So we are saying that if we have this certain state currently, so at the beginning, it will be a default state of our entity. When we got the event shopping cart initialized, then we are updating or setting the information, this specific information for the specific entity. So if we got following sequence of event that at first cart was initialized, then we are setting ID, client ID, and cart state, shopping cart status to pending. Then when we are adding new product item, then we are adding that to our collection. Again, if we are removing, then not surprisingly, we are removing that from our list of product items. And when we got shopping cart confirmed, then we are setting status to confirmed, etc. And I'm using here a syntax from C#9 and related to records. So it says that switch this event, which is object. If it has type shopping cart initialized, then deconstruct record. If someone is using TypeScript or JavaScript with ECMAScript recent versions, then it's similar syntax like there. So we can deconstruct our object and without the need to like do event.cartID, etc. So it's a weird syntax, but I like it because it's pretty well documenting what's going on. And as records are immutable, then when we get the specific state of the end for the entity, then we are saying that we are generating new instance with the new data. So it's quite fancy syntax, but if you don't like it, then you can just run for each and mutate the state and not use records if you don't want to. In general, it means that we will be calling this method for each event and applying new state based on that. So how to do it? Let's define what is our default state, because we need to provide it here. And our default state is, we will define just a static method that will generate a new shopping cart with some dummy data and empty product items list, because that will be easier for us. And let's do some sample. Let's go on top. Oh, see, I'm not great at copy and pasting. And let's see the classical example. So we have some client that will be represented by ID, and we have our shopping cart. And let's say that at first we decided that we would like to buy some shoes, one pair of shoes. And then we decided that maybe we will buy 2 t-shirts. They are Christmas, so Christmas gifts, etc. And after that, we recorded such sequence of events. So at first we initialized our cart, then we bought some shoes, then we bought t-shirts. And after that, we decided that, I'm not sure if that's only in Poland, but there is a superstition that you shouldn't give shoes as a gift because that's a bad luck. So we reminded about that superstition and removed those shoes. And after that, we confirmed our cart and pushed the process forward. And precisely that's how we can get also our events from the database afterwards, and we can clearly see what has happened in our system for this particular shopping cart. And again, how to get the current state of shopping carts from that events. Let's imagine that we read such events from EventStore. So we can use an aggregate method. An aggregate method is from Linku. So it means that starting with this default state, for each of events, call this method. And this method, when we already know, so it takes the current state, uses object from enumeration and returns new state. So it's like we are aggregating the state based on the collection and the initial one that we provided here. So in general, that's how it looks like, and that's how we are doing that in event sourcing. So after we aggregated our state, then we can run a business logic precisely as any other approach. So let's define how our command handling can look like. So let's start with defining the initialize shopping cart. Let's go to the bottom. And initialize shopping cart is nothing fancy. I'm again creating a command. So it's an imperative form intent to do something. So in this case, initialize shopping cart. We can do some validation to make sure that data in the command is fine. And after that, we can define handler, and handler takes a command, runs some business logic. Let's imagine that this is business logic. And as a result, we are returning new event. So in this particular case, shopping cart initialized. Okay, but that's that's not a business logic. So let's define something that we could name a business logic. So adding product item. So for product item, we again defining a command, add product item for this particular shopping cart, this specific product item. Product item is just a product ID and quantity. So nothing fancy. Sorry. And yeah, let's go here. And we are again defining our handler. We can still inject in our handler some external code, like a product pricing calculator, but the rest is exactly the same. So we are using command, and here, as this is update, then we are also need to have our current state. So we are doing here some business logic, some checking if the cart is in fact pending, because we cannot add new product to confirmed cart or canceled. We are calculating the price of this specific product item, and we are creating new event. So again, we have comment, we have state, and as a result, we are getting new event. It won't be surprising that removing will be exactly the same. So we are sending product item that we would like to remove. We are making sure that we can remove that product exists. So here there is a bit of hidden logic, because shopping cart has product items list, and I created it as a value object that has some logic. Like if we are removing product item, then we are at first trying to find it. If it wasn't found, then we are throwing exception, because we cannot remove what's not existing. And after that, we are removing this item, and we are also making sure that we have enough product items. So yeah, we can compose our business logic, we can put it here, but in general, it stays the same. So command, state, and the result. And the final command handling will be the confirmation, and that's exactly the same logic. So command, which is a simple DTO, and function. So it's as you see, you don't need to do it as I'm doing. So using the pure functions, you can put those methods directly in your service. We will go afterwards to see how we could do it in practice, in some more real world example, but more or less that's all. We can just, focus on the business logic, and after we recorded an event, we can think how we can build our read models based on that. And okay, but still, that's probably not looking really production grade code. So let's try to make it more production code. And let's use EventStoreDB here. So let's write few extension methods. If you prefer, you can use repository here to wrap the processing. but I'm just extending what we already have in EventStoreDB. So we will have two main methods. One is find, that returns us the current state of our stream, and append, which just appends new event. So we will be using EventStore client. EventStore client, the one is run by gRPC. We have also clients for other languages like Go, Node.js, Rust, Haskell, Java. I'm not sure if I missed something, but yeah, it's a general usage tool, but we'll focus here on .NET. And the basic thing that we will be doing is reading from stream. And reading from stream has multiple parameters, but the most classical case is that we will read all of the events. So we will read from start and we will read forwards. So we will, in fact, read all of the events for the specific stream. If we'd like to, we can do it the other way. So we can say that let's do it backwards and from the end, or set how many events we would like to read. But that's typical case is that just reading all events. And after that, again, we are using the already known aggregate method, but here we are using aggregate async method because EventStoreDB is returning the async enumerable, which is more memory efficient. So we are just reading event one after another, and so we don't need to load all at once. So it's more memory efficient, just in case we had really long stream. So we are taking the events from EventStore and deserializing them. I'm using here just JSON, but underneath, as you can see, EventStore stores everything as a binary. We can store JSON, but eventually it all ends up as a binary. So it's up to us to decide what type of serialization we would like to use. If we want to optimize, we can use like a protobuf or any other storage format. So again, we are reading all events and using aggregate method to apply event one after another and build the current state. And then we have two methods for appends. The first one is just for adding new event. So we are assuming that there is no stream, and this is important fact. And that's the important to understand, as it's different from, for example, Kafka and any other streaming solution, because EventStoreDB and EventStores in general support strong consistency on writes. It's not true that they are eventually consistent on append, and you cannot guarantee. And we will have the strong consistency, and we will know whether the specific event was appended. So in EventStoreDB, all operations are atomic, plus you can use optimistic concurrency. So optimistic concurrency verifies whether the stream state is exactly the same as expected, and we are using for that stream version. So that's why I'm said that each event will have a new number. And let's get back to our presentation. Okay, I will have later on slide about that, but each event has auto-incremented number. So shopping cart initialized will have 1, product item added will get 2, etc. So when we are reading events, then we shall read also the specific version and the current state. And we are sending that version together with our command, and we are passing that to EventStore. And EventStore will verify whether the specific version is equal to the version of the last event in the stream. So we have strong consistency here, and that's really important to understand, because quite often a lot of people says that in event sourcing you have eventual consistency, and you don't know whether you are making decisions on the latest state. But all of the event stores that I know supports store consistency on write. Not all supports on read. So as we get later on to the projections, we'll see where that superstitious comes from. But yeah, for now, we can see that we can have the strong guarantees here. And I will show you how that looks in EventStore. Let me find the proper browser window. So this is UI in EventStore. So we have a stream browser, and I already set up some dummy data for showing the shopping cart. So in EventStore, streams usually have prefix, and this prefix is usually the type of our entity. So for example, shopping cart. And then after the dash, we have ID. And as we see, we have a sequence of events. So the first one is shopping cart initialized, then product item added, again added, then product item removed and confirmed. And as you see, all of those events have numbered auto-incremented, and we can use this specific number for our optimistic concurrency versioning. If we go to specific event, then we can see that they are just JSON. UI can interpret that if we said that this is a JSON event. And in general, that's exactly the same how it works in other event stores. And let's see again how we could model that in the real world example. And let me find the proper code. So we could build following extension, following method. Handle create command. It takes event store handler, so a function that you already saw. We need to get stream ID from the specific command, and after that we are running handler, getting an event as a result, and just appending that to event store. So it looks more or less like we already have in our dummy code that I live coded. And for update, it's similar. So we are getting ID of the stream from our comment. After that, we are getting the latest state, passing that through to the command handler, and getting event as a result, and also passing the version that we are sending in the command to fulfill the optimistic concurrency needs. And we can provide some extension methods. So we can still use dependency injection if we prefer. So we can define add create command handler, which will just allow to record a specific function. So a pure handler. It just takes and calls the handle create command that we see above, and the same for update command handler. And this code might not look precisely clean, but let's have a look how we can use it. So let's go to the module. And we can define following syntax with the simple builder pattern that for the shopping cart, this is our default state. So the one that we are using to build the current representation. This is when method. So the same as we defined previously. So that's exactly the same logic. And after that, we can say that for initialize shopping cart, we will be using add logic. So we will run the command handler. This is how we are getting the command ID from the shopping cart ID from the command. And for other commands, we will be just updating the state. So we can also say that for add product item shopping cart, use this specific handler. And as you can see, we can inject from the dependency injection product some external service and run the logic. And exactly the same here. So we are saying that update, we will be getting the current state, running the handler with the specific version. And the builder pattern looks like similarly. So we are just simplifying the registration patterns that we already seen. So in my opinion, this is quite clean, and especially that it can be used also as a documentation, because we clearly see what command we will be handling for our specific entity. And we can use a simple pure functions that are extremely easy to test, because we don't need to have a connection to database. We can just say that for having such command, we expect such result, etc. So that's quite clean. The sample is already on my repository, so if you'd like to dive more into that, then I encourage to do it. I see that there is a lot of questions, so I will try to be quick, because I would like to show you also the projection example, so how to build the read models from events. So I will answer those questions afterwards. And thanks, Eve, for moderating the chat for me. So let's go to projections. Let's have a look on this, this old photo. We can see here Muhammad Ali and Sonny Liston. And why am I showing you such an old photo? It's that it's a good representation of what's the projection. And projection is just a different interpretation of the certain set of facts. So for example, events. In this case, Muhammad Ali won the fight, and it has totally opposite emotions that Sonny Liston. I'm not sure if Sonny Liston has any emotions at all at that moment when the picture was taken. And what's interesting, that for the publicity, it was totally different experience, because this fight is the punch that Muhammad Ali did is known as a phantom punch, because no one saw that punch reaching the face of Sonny Liston. So some people said that it's made up and it wasn't a fight. So as you can see, the same fact can have a multiple different interpretation. And it's precisely how the projections are working. So we are just taking a set of events, interpreting them, and getting the result. And typically, the result is a new materialized state. So in event sourcing world, we can take a sequence of events from the stream and materialize that and put it into some dedicated storage that is good for storing those information and like for filtering, etc. Because frankly, for example, EventStoreDB is not great for filtering. It's great for storing events and processing events, but not for querying and getting more sophisticated filtering. So typically in event sourcing, the event stores process events, and after that it publishes notification, and then we can build a dedicated read model from that. And we can build from the single stream, but we can also take events from the multiple streams. So for example, here, we can build a user cards dashboard where we will see all of the users with their shopping carts and the current state of their shopping carts. So what's the step in the life cycle they are at. So in this case, we will take some events from the user stream and some events from the shopping cart stream. And how that projection apply logic works. So we can take a first event, for example, cart initialized. And if we are storing that data in a relational table, then we can create a new record in the relational table. After we get the product added, then we may update data in the specific table. So for example, increase product count. And again, after cart confirmed, we can update the shopping cart status and set it to confirmed. So this approach is called left fold because we are taking events, so from the left side, and applying them one after another, flattening, folding the events into the state. And read models, the results of the projections are typically used for queries. So that's why event sourcing works pretty well with CQRS, because by nature we are splitting reads from our writes. And what's important is that a single event can update multiple projects and trigger updates to multiple projections. So for example, when we are adding a new product, then we need to decrease the product availability because we don't want someone else to buy product that's not anymore in inventory. We are changing the cart state, and we can, as I mentioned, update the carts dashboard. What's more, we can trigger some further workflows like sending email that product was added, etc. And projections not only can create read models, they can also create events based on events. And that's how projections in EventStoreDB works. So in fact, they are just transformations. They are taking some set of events and generating a new one. And that can be useful if we are building some chain of workflow. So we can take cart confirmed and then trigger another event and store it. And it's not like read models in event sourcing have to be eventually consistent. For example, in Martin, so as we are using relational storage behind that, it's possible to update read models in the same transaction as appending events. Of course, if we want to be scaling further on, then that won't probably scale well, especially if the projections will have more sophisticated logic, or we'll have a lot of projections triggered after the specific event, but that's doable. It's just a matter of the trade-offs that we are choosing. In EventStoreDB, we have a mechanism called subscriptions, and we have two types of subscriptions. One is persistent subscriptions, which is implementing the competing consumers pattern. So it's close to how Rabbit works. So we are publishing event, and the first subscriber gets the event, then it will be handling that. So it automatically allows to scale projection handling, but it has downside because it doesn't guarantee ordering. But we also have catch-up subscriptions. You need to implement a bit more, but it guarantees you the ordering, even global ordering. And subscriptions can be used to build read models, for example, in Mongo, Elastic, Postgres, etc. But it can also be used to push the events forward, for example, to Kafka or Rabbit or other queues. But they can also be used as some messaging solution, as a streaming. So if you don't have extreme throughput, then you might consider not using, for example, Rabbit or Kafka, just use subscriptions. It's not like, of course, you need to verify and check what's the useful case for you and whether performance is good enough. But yeah, subscriptions is quite generic pattern, like a publish subscribe. And what's important is that projections are deterministic, because if we have the same projection logic and we have the same set of events, then they will always generate the same result. This is really important because that means that we can rebuild our read models. For example, if we had a bug in our projections logic, or for some reason some events were lost or whatever, then we may decide that we will regenerate our read model, because events are the source of truth. So as we have all of the information inside events, then we can clean the wrong read model and build it since the beginning. And we have two main approaches. One is the in-place rebuild. So if we can allow to have a downtime, then we can truncate the current read model, and we can take events and again apply them one by one. But of course, nowadays, everyone wants to have a blue-green deployment, and that's also doable. So for zero downtime, we can create a new read model in parallel, for example, a new table, new scheme, new collection, etc. And the queries will be still happening and occurring to the old one, the old read model, and we will be applying all of the events to the new one. And after we caught up, then we can replace those read models, and then queries will go to the new one. Of course, we need to be aware that if we have a lot of events that are used for this read model, then that might take time. For example, in one of my past projects, one of our architects wanted to replay all the events that happened in our system right before the demo. And it appeared that it will take 2 weeks with our current resources to reapply all events. So it's not doable. However, I was talking with my colleague and he said that for his business, it was fine that they could live with this potentially not correct read model and have this longer rebuild, as long as after some time it will be correct. So again, we need to be careful on that, and short streams can help us in that, because if we have shortened streams, then we might have less events to rebuild. So it's not like it's a magical thing, those rebuilds. We still need to have some trade-offs and think about how to work with that. But yeah, it's an incredible benefit if we are using that wisely and consciously. So let's get back to our code. I will try to show you how read model processing will look like. So let's see how read models looks. And I'll be using entity framework because I thought that, well, why not? Let's use some ORM to just prove that you can use any tool. If you can use ORM, then that means that you can use any other tool to build a read model. So read model is usually some DTO, like a simple data. We will have 2 read models, and that's the classical case. The 2 read models will be generated based on the same set of events. One is details, and that contains the snapshot information about the current state of shopping cart. So all of the information that we could have. And we will also have the short information that will be used on the list. So see, we don't have list of product items, but just total count and total price. So basic information that we would like to see on the list screen. And let's have a look how we can update those projections. And maybe we can start with short info. So again, we can use a simple handlers for that. So we don't need to use any sophisticated logic. We can if we'd like to, but let's keep things simple. So it's a similar approach as we had in our state aggregation. So we are taking event and we are returning new state. So let's say that we are adding new shopping cart. So we shouldn't have any current state because that should create new record. So we are just setting the basic information from the event to our read model, and we are storing that result as in the target database. We'll see how to do that. When we got shopping cart confirmed event, then we are just updating the status. So we are just updating a single column in the relational table. If we are getting product item added, then we are increasing total items count and total price. And if we are getting removed, then we are decreasing. So that's simple as that. That's how projection code looks like. And again, it makes it predictable. We can even unit test that or integration test that by just saying that having such state, when we get such event, then we expect that it will be updated in that way. If we have a look on the details, then it's exactly the same, but with the distinction that the logic is a bit different. So we need to provide some basic logic for adding new item, or if we already have that product, then we are just increasing quantity, because we don't want to add new row for the same product twice. And for removing, again, some simple mapping logic. And as you see, the code is really simple. And some people says that it's not easy to unit test event sourcing application. And in my opinion, that's not true. I hope that looking at the code that I showed today, you will have the same impression. And if not, then Eve have somewhere a webinar that is available about unit testing and in general testing event sourcing application. So search for that if you'd like. And let's have a look how subscription works. So subscription, as I said, it's a publish subscribe pattern implemented by EventStore. So we can say that subscribe to EventStore, and we have two options. One is to subscribe to specific stream or subscribe to all events. So I will use subscribe to all because that's the default that I would recommend. So to just subscribe to all events and then run all the projection handling for the specific set, and only optimize when we need or parallelize if we have more performance. So as you see, there is this weird if that is doubling the code. Well, it's almost doubling, because if we are subscribing, then we may say that from which position we would like to subscribe. And if you were using Kafka, then it's similar to commit offset in Kafka. So you can reset a commit offset in Kafka and get the events again. And the same way in EventStoreDB, you can say that you want to subscribe from start, so get all the event notification about all the events that happened in our event store, or we may say that we would like to subscribe from the certain position. And let's go for a moment to slides, and I will explain you the positions. So as you already seen, each event in EventStore within the specific stream, they will get an auto-incremented number. And this sequence is unique for the specific stream. So you might have, like the shopping cart one will have a stream revision 1, and the other cart will also have stream revision 1, because that's unique in the particular stream. But we have also a concept called all stream, or as I mentioned, append only lock, where we are adding all events. And in this lock, all of the events get a unique position. And this position may be gapless, may have some gaps, because it's a logical position representing the position at the disk. But what's important is that is monotonic number. So each event will have number bigger than the previous one. So let's say that something went wrong after we processed those 3 events, then we might say that we would like to start from the beginning and subscribe and reprocess all of the events. Or if those 3 events were fine, but this event, so with the number 200, provided a bug, and we know that we processed those 3 events properly, then we might say that, yeah, let's try again from the last successful position. So in this case, it will be 130. So that's why we need this position. And we need to, if we are using catch-up subscription, then we need to maintain this position and store it on our side in persistent subscription, we don't need that, but it's handled internally, but then we don't need have the ordering guarantees. And what we are passing here is the handle event callback. In handle event callback, we will get for each event, this callback will be called at least once. And what we can do is verify whether this event is not a system event and publish that internally to some internal event bus. And publish method, what it does, it just takes event, already the serialized event, and is creating a new scope, because if we are using entity framework, then we would like to get, for example, DB context in the scope to have it properly disposed, etc., like in the web request. And after that, we are just running all the handlers that we registered. So in this particular case, the methods that I showed you before. So each of these methods will be called one after another. And of course, we need to do a bit more code into that. So let's go to see how we will be storing that directly into our relational database. So we will define two types of projection. One is for adding, and adding will just implement iEvent handler. It will automatically have injected DB context and the function, so the handler that you already saw. So it will be resolved by the dependency injection. After that, when subscription calls the handle method, so internal event bus is passing the event, then we will run the handler that we defined. So create would be, for example, that one, shopping cart initialized. So we are passing event and we are getting a new entity from it. And then we are just running regular entity framework code. So we are running add async, and after that we are saving the changes. And the next type of projection is, not surprisingly, it's update projection. Update projection also gets DB context, but it also gets a function because we need to know which row we need to update. So we will be taking some field, for example, shopping cart ID, to find the specific record. So again, we are using entity framework code, ORM. We are getting a record from database. After that, we are making sure, just double checking whether it's not null. And we are, after that, we are running our handler. What we are doing here, you will see in a minute, that's that we can tweak some of the DB context stuff. So we are, again, getting the record from database, running handler, and saving the changes. And how to do that? Let's get back to our configuration. If we scroll down, then I also defined a similar Fluent syntax for our projections. So let's say that we have such read model, shopping cart details, and we will be using this DB context to store information, retrieve and store information of our event processing. Then we can use a similar, as you already saw, for the commands handling, but here we are saying that for this event, we will use this handler, and after that, we will create a new record in the database. And after that, we have update on. It's again, we are saying that we would like to retrieve, because we will be updating. So we would like to find a record using this ID from event. Then we will run handler and see, we can still tweak the code. This was this magic invoke code. If you are using ORM, then you already know that. This code means that we are eager loading, so always loading the nested collection of objects. Entity framework requires that because our structure has the list, and we would like to load all that list because we will be updating it, adding or removing product. So after confirmation, again, we are saying that we would like to update following shopping cart with such ID from event. We don't need to load this product items, so we are not loading them, so not additional stuff. And this is extension that I will show later for querying. So for the shopping cart info, it's exactly the same. As you see, we have the same set of records, but we are getting different read model based on that. And thanks to that, we are making the case here that we optimized for reading, because in majority of systems, reads are happening much more often than appends. Of course, we will have more information in database, but storage is cheap nowadays. So that's why it's good to have dedicated models. But if we'd like to, then we could just use that one and then query the same table if we prefer. But that's not something that I'm showing here. So let's just have a look briefly on those methods. It's a simple stuff. So we are registering a bunch of functions in DI. We can register functions in DI. So in this case, if we want to get a function for ID, then we can inject that. We are also setting the handler, an event handler, etc. So nothing fancy. It's just a bunch of registration method for all of that. Event handling for projection is, as you see, 143 lines. So it's a simple code. The builder pattern might not look so clean on the presentation. I hope that you are following my thought process. But if you don't, then there is on my blog, there is a dedicated article on this particular example about the projections with entity framework. And you can also debug the code. There is already in my sample repository. And the same pattern you can use for MongoDB, Elasticsearch, or any other stuff. You might not want to use object-oriented pattern. If you want to use just a simple SQL, then in your handler, you might inject, instead of injecting view, you might inject, for example, Dapper or just SQL connection and run simple updates in this handler logic. So it's up to you to decide how to optimize that. For sure, what I'm showing here is probably not the most performant code that you can get, so you can optimize. But I hope that using this pattern, you can build from that. And in general, that's the approach that I think it's flexible and allows you to move forward. And let's just have a look on the last part. So queries. For query, we have also simple handlers, and entity framework handler is my logic. So I'm just taking the DB context and specific result, and I'm assuming here that we will be returning what we will be querying. So I'm just doing here a simple magic like as no tracking, as queryable, because we know that we won't be changing data, then we can use disable change tracking and get some performance benefit. And let's see how the query handler can look like. So it's a simple function. It gets queryable, query object, and runs some query on entity framework. But here you can, again, instead of queryable, you might inject just SQL connection or Elasticsearch client or Mongo client or whatever you prefer. So that's the simple approach. Of course, if you don't want to use those pure functions, then still you might just use mediator with the classes, etc. But I think that having such approach makes the code more testable, easier to understand once the basic boilerplate code is done. And it's done, so you can just copy and paste it from my repository, and tweak it for your needs. And from the presentation standpoint, that's all. I hope that I show you the basic building blocks on how to build event sourcing, that after that you will know, if you didn't know before, what's event sourcing. And it's not about messaging, it's about having events as our source of truth, as being close to the business. So that's probably why Valadis and Kostas invited me, because it's aligned with the DDD principles. So for me personally, the most important aspects of that is that it helps me to create code that is closer to business. Just a small digression. Like after 7 years of my career, I did some thought process, and it appeared that after the first 7 years, I only put on production 3 applications. One was a simple Facebook app for coupons generator. The other one was fine. It was even delivered on time and on scope, but it appeared that scope was wrong. And the third one was pretty big, luckily. It was quite big ERP system. And I know even people that are using it, which is nice. But still, 3 systems on 7 years, it's not great. So I started to think how to make it better. And so far, event-driven approach is the best what I found. So it's like a democracy. Maybe it's not the best, but for me, it's at least not the best, currently the best I found. So I really encourage you to have a look on event sourcing, play with it. If you want to play with it, don't start with refactoring your major module. Start with something small, because if you break this big module, then your colleagues will say like, yeah, Oskar, you already tried to use event sourcing, and we all remember how that ended up. So start small, grow big. And that's what I wanted to show you. I'm quite active on internet, so I will be happy if you send me some feedback through my email, through Twitter, whatever. I think that it would be easier to find me because I'm famous spammer. So yeah, thank you all for watching my quite long talk. We will go to the questions. I saw that Yves is a great colleague. He answered a lot of them, but I will try to go again and answer what's not answered, because we have 23 minutes left. So yeah, thank you.
All right, thank you, Oskar. It was really, really dense. Lots of information to digest. Hopefully, everybody interested will just visit your repo and try to do some hands-on, trying all these things on his own. And of course, I guess he can contact you for more for help or any questions in practice. But until then, I think we have time to take a few questions from the participants. So, guys, if you have something to ask, just raise your hand or just unmute yourselves and go ahead.
Yeah, we can probably start with brave people that want to use voice to ask questions, and then we can go forward with what's on the chat. I see Eve is raising hand.
It's not a question. I just want to say that I've kept a difficult question on the chat for you.
What's that? What's the most difficult one you didn't answer?
I don't know. I've looked at it. I've looked at them, and oh no, not that one.
Okay.
No, joking. But there are some. Okay, there are great questions on the chat.
So yeah, Eve helped us and answered most of them. And we also tried to help, hopefully, with the right answers. But So the last one is, let's start from the end. So the last is, you never mentioned aggregates. What's an aggregate? Is it what you call state? That's by Mark.
So maybe let's go to my sample. So I'm using here entity, and I'm not using here aggregate pattern. So this is entity. So it's an anemic model. If you are using this command handling approach, it's kind of functional style. So you keep your data separated from the functional logic, then you might not need aggregate, because in fact those handlers are making sure, and event store after that is making sure that your state is consistent. So that logic you would typically put in the aggregates. However, I think that I even have the shopping cart aggregate here. So no, I have too many shopping carts on the dance floor. Sorry, probably I'm using, okay, I'm using wrong rider. Let's bring the third rider here. I think that got, okay, maybe let's go with the reservation. That's one. Yeah, so the other approach that is quite popular, especially in DDD community, is using aggregate. So you are setting all of the business logic, and you are including that in the specific code structure. And this code structure is like entity on steroids. So it's like I have the, if you remember this meme about the Puch, like, you know, the regular one and the posh one with the suit, then entity would be the regular Puch, and aggregate would be the posh one. So besides keeping the entity state, you are setting that by default as private, and you are exposing all the methods. So the methods, see, those methods look similar as what I had in my command handlers. So the command handlers that I show, you could translate and put it together with the entity and keep it in the same state, together with the state. And then you have the Morex encapsulation and all of the benefits that DDD is glossing. I don't mind this. For me, it's just a style preference. If you are using that approach, then typically you are having two methods. One is apply. Apply method will be used to just apply the state. So it's what you saw in when method. So for each event, you need to define how you will be applying the state for your event. And also, if you are running the logic, then you can call the same method and get the current state. But besides that, you need to somewhere store those uncommitted events, because if you are doing DDD aggregate, then typically you don't want it to return event, because it should be storage agnostic in general. At least that's how I interpret it. And so typically you are having some internal uncommitted event collection where you are just enqueuing the current event. It is collection because you might be the single aggregate operation in theory could create multiple events. And after that, you can use this particular events. And if you are running store method, then you are getting those enqueued events, and then you are calling the append to stream method that you already know. So it's exactly the same. It's just you know, potato. So depending on what you prefer, then you can use one pattern or the other one. I won't judge what's better. Functional people will probably say that the one that I show on the presentation is better, and more object-oriented will show that aggregates are better. So, yeah. Okay, let's. I saw, Mark, that you raised your okay. Then yeah, I'm happy.
Do you have another one? Have you found another one, Oskar? Question? Yeah.
Yeah, sure.
Go. Were you about to like read the question from the?
Yeah,
or should
I can read. Yeah,
go,
I can
go,
read.
go. Yeah.
I'm scrolling from the down. How would you handle bulk operation command like update my aggregate stat, where status equals pending, but in event source system? That is bulk operation. This happened after event source system was supposed to introduce the feature. Unfortunately, in event sourcing, that means that you either should have that's the desired way. So you should consider this different design of your streams. So for example, have a streams for a collection of aggregates, or at least the entry point, not precisely keeping all the events for all aggregates, but for example, let's say like, I don't know, user shopping carts or etc. And that would require probably some process manager. Or the other way is, unfortunately, you would need to create each event for each stream. Because if we are doing event sourcing, then each change has to be eventually stored as event. So bulk operation, if you need them, then I would consider discussing with business how that precisely works. Because from my experience, quite often when someone wants to have bulk operation, then usually it means something different. But yeah, if you really have to, then yeah, unfortunately, you will need to create as many events as you have streams. So it's not great. So in that regards. But for example, in that case, some people are using tricks like publishing event and using some temporal processing, like I mentioned, process manager. So doing step-by-step approach, or having some flattened version, like a read model. It's not a pure event sourcing approach, but it might be good enough for some cases. Event is something that happened in the past. What it takes to execute a command to produce a file downloaded event. Do you create an intermediate request event? Yeah, I mean, I'm processing that how I show. So typically you need to have some comment. You might not even call it comment, but it needs to be business meaningful. It can't be like a create, update, delete, because then you don't know what's precisely has happened, what business operation has happened, and your event won't be also giving more information. To have business meaningful events, you need to have business meaningful requests and comments.
But you wouldn't usually create intermediate events. You would just have a command and then the event, right? In like,
yeah.
I guess that was the question. So you would just receive the command and then you would just, if everything's okay, you would produce the event.
Yeah, yeah, exactly.
So,
and I'm not sure if that's the case, but sometimes people are like, for example, email sending. I'm getting a lot of questions like people needs to store whether email was sent. However, email sent is typically not handled like you are scheduling event, not sending event, because typically you are using some external service, or you are putting that into some queue because you need to some resiliency, right? Because emails are not just sent typically because you will be hit by spam filter, etc. So typically people are trying to store like email sent, which is not good event for that particular case. You should rather store what exactly has happened, so you don't know whether email was sent. You can store that email was scheduled. And if you have some, for example, webhook from the email provider that the email was sent, then you might store this event if you need it. So I would recommend to always focus on, and also making sure that we are not lying in our events. So just stating as it is. I saw some question about simple SQL and isn't entity framework overkill? It is.
Yeah, there was a debate about ORMs in the projection side, basically.
Yeah. So I mean, I'm quite happy that I haven't used ORMs in my commercial project in the last few years. So I'm not a huge fan of ORMs, but I understand that they're doing job. So that's also why I show precisely entity framework, because as I mentioned, if you can do that with entity framework, then you can do that with anything. So as you are injecting that with the dependency injection, and you are having the handler method, then you can inject in that handler whatever you choose. So you can use raw SQL, or for example, in Mongo, you have this atomic tiny operations that you can do. For example, just add item to collection without rewriting whole document. So they are more performant. So I wouldn't probably recommend using entity framework. I would suggest probably to use some more optimized, but if you don't need like extreme throughput, then that's I think that's fine. I don't mind if someone likes ORMs. I don't mind, and if they are doing job, you know, if something looks stupid but it works, then it's not stupid. Okay. Eve, do you remember what was this hard question?
Let me find it. No, wait.
I saw questions about events. Yeah, that's why I don't recommend using snapshots, because snapshots quite often gets out of date. So if we are caching snapshots, then eventually we will be facing the issue that our entity structure has changed, and our entity structure tend to change a lot, because that's the entity and aggregate structure should be provided for the ease of the development. So to make our development life easier and to express our domain concepts, and they are changing much more often, our vision, and because, you know, we always want to tweak that, like, let's rename that one part, let's make it a bit different. So the entities and aggregate structure tend to change quite a lot in my experience. So then you need to think how to do with the snapshots. So if you have snapshots, then you will need to use those tactics that I mentioned for the read models, because snapshots are in fact read models. What's more, you need to remember that snapshot is always stale data. They might be not the same. So you might need to rebuild them just like any other projection. Quite often people that are using snapshots are just getting snapshot with the version at which it was snapshotted and then loading the rest events that happened afterwards. It's quite safe in a way if we are using optimistic concurrency, because even though we will get stale data, then EventStore won't let us store that event based on stale data. So that will mean that we need to read again and retry our logic or decide that we don't want to retry because already someone confirmed, like our wife confirmed our shopping cart. So yeah.
I found it. Postgres for storage, good choice. Any problem in your experience which you have with Martin?
No, I didn't have any problem. Postgres is called rock solid relational database, and that's precisely how it is. So if you want to use relational database, use Postgres. It's a great database. And about JSON support, I saw even some benchmarks that JSON support is Postgres is faster than in Mongo. So yeah, and it's the syntax is quite weird. You can get used to that, or you can use tool like Martin that will do it for you. I think that even entity framework, infamous entity framework has something. I know that NPG SQL team provided some basic mapping. So yeah, I have no bad experience with Postgres. If there was bad experience, that it was probably me doing some weird stuff and breaking something. Not, I wouldn't sign that as a Postgres issue. I mean, the thing that I could probably see is that publishing notifications about events. So you would probably need to implement either your own outbox pattern or build it something on wall, so you don't get push notifications out of the box like you have in, for example, EventStoreDB. I mean, in Martin you have, but if you want to build your own solution, which I do not recommend, don't build your own event store. I have some talk and even example how to build that on top of Postgres, but do not build your own event store. That's much harder to do than it seems to. So even if you manage to build such event store, then the question is whether you will be able to maintain it. So I'm not just do your research. You can use EventStoreDB, you can use Martin, you can search for other like Axon or other solutions that that are mature and have some active supporters behind that. So yeah, that's what I would recommend.
There was another one about projections from other projections, which like this was mine. It didn't know about that basically. Initially that sounded weird. So you can create, I'm used to like create projections by the event. So you list consume the events and you create different projections. But in some cases you can create projections from other projections, which I guess it's okay because the first projections are deterministic. But why would you do that? I mean, what's the use case?
So I would only do that if it's a specific set of projections, so transformations. If those projections are generating new set of events, then I would use it. But if it's like I'm having some read model as a result of one projection, and then I'm using in the other model, in the other projection, for example, we have schools and teachers, school classes and teachers, and we would like to see the name of the teacher inside the school, the school class read model. So if you are reading the name of the teacher from the other read model, then you are coupling them together. So you cannot autonomously rebuild them. You need to rebuild both of them, because if you have this coupling, then it creates some relation. It might not be that bad, but majority of cases when I did that, and when I heard that someone did that, then it ended with small or bigger pain. So that I'm not recommending that. For transformations, so the first one, I think that's quite useful, especially, for example, I mentioned that, but maybe not enough explicitly, that event sourcing should be considered on the module level. And for example, you should not be publishing to other modules all of your granular stream events, because if you are doing that, if you are publishing all the events, granular events from your streams to external modules, then you have leaking abstractions. For example, reservation process. A financial module don't care about unconfirmed reservations or all of the changes, like someone changed type of room from one to another. They just care about the confirmed reservation to create an invoice. So I would, so in that case, you could use transformation, for example. You could use it to get the confirmation event, and then do transformation to enhance it, enrich it, to get more data from the other events, like get all the current state and build more richer event with all the information for to publish that to the external modules. you can build also like some transformation that will take, for example, do some migration, like you have a set of events and you are changing that into another one, for example, with the changing the structure or interpretation. So that's what I would probably consider as valid cases for projections from projections.
May I add one thing?
Yeah, sure.
It's because there's maybe one thing that hasn't been said explicitly. EventStoreDB has a projection, an internal projection engine where you can, so you get events in, and the thing is you can automatically create new events and push them to new streams. So there's a bit of transformation there happening. And so that's kind of the thing you can do, but that's something you can do also in your own code. Listen to events, create new events that you push to new streams because you're making new decisions and that affects another stream, which is typically another entity in this case. So that's one of the things that can, so reacting to events. So in the beginning of the presentation, there was this, the drawing, the picture that explains almost everything. If you follow the lines there, you will see that sometimes you have events to events. That's a thing. You can derive new information or from information you got.
Yeah, so that one.
Yeah. So you can create new events from events.
Yeah.
Which might sound strange, but it has interesting use cases.
Mm-hmm. And I think
it's hard to debate with event storming, isn't it? I mean, it's not like event storming. Sometimes like people disagree. I mean, but yeah, I wouldn't name people, but there are different opinions on that.
Yeah, just small please from me. If you consider using EventStore and our internal projections, do not use them as read models. Just you will give me a favor and our support team and yourself. Yeah. I see that there is a question from Mark that might be even related to this image. So how do command handlers interact with event streams? For example, shopping cart command handler might want to check whether a user is actually active or banned. So I think that the choices are more or less the same as in other cases. So the first one is that you can read data from other stream or read model, but then your read might be stale. So you don't have that guarantee that based on the read, you will have a proper information. And that's a common event for relational databases. Because if you are reading, then between where you read and you're storing, state might have changed. So if you are reading from other place, then it's always might be stale. In event stores, you can in relational databases, you can put a unique constraint, and that's all. So if you are using relational database behind the event store, like in Martin, then you can also put a unique constraint inside of that. However, of course, that's probably what I would recommend at the end, because typically behind this unique constraint, there is some other business requirement. Usually when we are hearing about the unique constraint, at least that's my experience. Usually when I heard like that, like a set-based validation, then it was that probably business came us with a solution instead of problem. So they trying to explain us how we could solve it because they, catching our technical terminology to help us. But instead of that, usually it's not always like that. So quite often it's fine to not validate that and just put a compensating operation if something went wrong. But then, of course, we need to listen for events and do some metrics and alerts based on that. So if we want to be like really sure that we have this unique constraint, then for the shopping cart, if there is always a single shopping cart for a user, then we can, for example, put a user ID in our stream name. So stream name would be like a shopping cart, and then it would be user ID. And we will have only single shopping cart for the specific user. And EventStoreDB do not allow to have more than one stream with the specific stream ID. So that's the case. However, it's not always working, and especially for more advanced unique constraint checks. And for that, there is also reservation pattern, which means that at first we are trying to reserve some specific resource. For example, shopping cart for a user. And then we can create a new stream that will have all of the information that we need. And if it wasn't already reserved, then we are running our business logic. But if it was, then we will get an exception and our logic will be canceled. The hard part about that is when we succeeded with the reservation, then we are running business logic, but our append failed for some reason. Then we need to roll back our reservation after some time to not have some resource reserved for a longer time. So my recommendation is to start with making sure that this is the really valid case, business case, and we cannot resolve it softer. But if not, then depending on the event store you are using, then you might have such solution as I mentioned.
Cool. I wanted to ask another one. It's a quick one. So I noticed in the handler, so when you do something with a command, then in the handler you return one event, a single event. Is there a rule that we should always return a single event, or is like, well, in my case, I have returned multiple events in some cases.
Yeah.
Is that an anti-pattern, or what do you reckon? What do you think?
No, it's fine. It's fine. I mean, this is an example how you can do this, but you might not. For example, you might return both current state and event, or you might return current state with a list of events. So typically, there is a pattern called decider, and that was designed by Jeremy Chesson. I hope that I properly pronounced the French name. Probably not. So it means that you can have, and it defines that you can have multiple return data. If I would need to return multiple events, then I would just would like to be sure that they are business meaningful and they have the same correlation ID. So I know that they all occurred for this specific comment. So they are not like a chain of events. In majority, I think in 95 or 99 cases that I was using, I was just creating a single event after comment processing. But yeah, it's fine in some cases to return more than one. That's also why I showed in the aggregate example that we have here a collection of event, not the single event, because some business operation can create more than one event. And that potentially is some solution how you can handle batches, like generate here multiple events and store them even in multiple streams if you need to. However, just to highlight, most of the event stores I know do not support batch operation on multiple streams. On the single streams, they do, but not on the multiple streams. So you need to be aware of that. Okay. I'm not sure if I answered all the questions.
I believe we're quite good.
Yeah. Based on my scrolling skills, I think that I did. But if someone has more question, then I think that feel free to ask, because we already out of the time. So I don't want to keep you too long. I mean, I can answer them as long as they are, but yeah.
If anybody wants to ask something, they can just, unmute and ask directly if you like. Otherwise, we can allow Oskar to recover his breath and go on with the raft.
Yeah, let's not exhaust Oskar. I know. Let's yeah, let's do the thing.
Okay. So yeah, thank you, Oskar, for the link to your repo. Once again, we'd like to thank everyone, especially Oskar, but all of the participants for joining us today.
And Eve for co-hosting the meetup. Thanks, Eve.
We'll be wishing everyone Merry Christmas if you're celebrating Christmas, and hope everyone has a nice end to the year. And I guess we'll see you again next year.
Thank you.
All right.
Thanks, Oskar. Great talk. Hope we see you in
everyone.
person.
Thank you,
day.
Oskar.
Thank you.